Hello everyone. In this video we are going to talk about this project of naive Bayes Text Classifier. So it is a classification project. So what we will do basically here is that we will have some documents. We will feed those documents to our machine learning model, and then our model should be able to predict what exactly is the topic being talked about in that document. So similarly, like every other machine learning algorithms, we will have some training document as well as we will have some testing documents. So let us just start. Now the overall plan of implementation, we would just talk about that how exactly this is going to happen using those naive Bayes text classifier which we talked about in the last video. So first we are going to take all the documents and use all the words as its features and store its frequency too. So we would just iterate through all our documents. In a particular document, we will iterate through all our words and we would see how many times each word occurs. That is, we would store the frequency of each of the words. Now you can easily guess the words like a and the, his, her and stuffs like that. There would be a lot of words with frequency 1 or 2, and those words are going to be like quite insignificant. Like how many times the word the occurs in a document, it has no relation with what is being talked about in that document, right? So there would be a lot of useless words with frequency 1 or 2. We will just ignore those words. If it is a stop word, we will see what a stop word is exactly. So add the word, we would add the word in our dictionary with count 1 if it is not already present, else increase the frequency. So we would maintain a dictionary for each documents. In that dictionary, as I said, there would be the words and the corresponding frequency of that word. So as we would iterate through the words, so we will see if the word is already present in the dictionary, we have to increase the frequency by 1, and if it is not already present, we would just add the word to the dictionary. And then we will choose the top k words as our feature set. So whichever words will be having the most frequency, we will try to predict the topic of the document from those top keywords. So we are going to use the 20 news group dataset. So this dataset is basically something of like it contains 20 documents basically. So there are many classes also, and we just need to predict that what exactly is being talked about in each of those news groups. So we first import the basic libraries of NumPy and Pandas, and from dataset we import fetch 20 news groups. So this fetch 20 news group, like this is the syntax. It is predefined. You can check out in the documents and documentation. So this is used to fetch the training and testing data in a single variable. So we use this subset all and remove headers, footers and quotes. We don't need those for our manipulation of data. And shuffle equals to false, we can do that if we don't really want to shuffle our data. Now after we can just load the training and testing data separately also. So subset, instead of subset all, we will give subset train and test in, and we can store in them into variables. So in this case you can see that we don't really need to do the train and test split what we do for other algorithms. Here we can directly load the training data and the testing data separately. Then we can just, for our manipulation, we can just see the what are the target names, what is the length of the target names, what is the length of the raw data set, and what is the news group, what is the training data length basically. So actually there you can download this dataset from UCI machine learning repository and know more about these dataset. I think there will be 20 topics which can be the output. That is why their target names the length is 20. So what we are doing now is that we are accumulating all the sentences. So for I in newsgroup train dot data, for j in I dot split n, so we are just splitting our data by this new line character. So we will be having all the sentences after this, and we will just append the sentence in this list. So this list of sentences now contains everything which are separated by these new line characters. That is, it will mostly contain the sentences. Now for each sentence we will go through the list of words. So for each sentence we can just do split by space. So if we put nothing in the brackets, it means we are splitting just by space, and we can just append the words. So now our words list will have the list of words similar to the list of sentences, and we can see that we have this many words. Now we would try to find what are the English stop words. We can You can just type out this in the Google list of English stop words, and you can just create a list of them and store it in a variable. You can see that there are 1198 stop words. So these are the words. Basically you can see a and the and stuff like that, his, her. So these are the words which has no role in identifying what is being talked about in the document. So these are known as stop words. And for new word we create a new word list from which we are removing all the stop words. So for element in words, if element dot lower not in English stop words, then we would only append the new word, the word in the new word list. So you can clearly see that the length of the words was this much, but the length of the new words is this much. So length is reduced. Why? Because all the stop words have now been removed from the documents, and we are having more or less only the useful words. Now we can just build the dictionary with the count of each words, as we said in the initial starting of this video. So we would create a dictionary, and for each we will iterate through each of the word. If I is not in the dictionary dot keys, then dictionary of I is 0. That is, we are just assigning the new word in the dictionary with frequency 0, and else we would just increase the count. So yeah, that's how our dictionary would look like. And we can just sort the dictionary in terms of the descending order of the values. So these are known as the keys and these are the values. So in the descending order of the frequencies we can just sort the values. So sorted values equals to list of dictionary dot values. So we create a list of values and we just sort the values in the reverse order. Now the sorted dictionary would contain, so for k in sorted values, for k in dictionary dot keys, if dictionary of k equals to I, sorted of date equals to a I. So this break is done basically. So because we want to increase our efficiency of the code, if you can just think of it, when we go through all the keys from in the sorted values, we are already having the sorted descending order way, and we are just going through the keys also. So if dictionary of k, so if the value is equals to the sorted value, then you can put the sorted dictionary of k equals to I. So this sorted dictionary will contain all the values of. So what is being done, basically we have all the sorted values. We suppose we select the first sorted value and then see which value is this, does the dictionary have, what is the key corresponding to this value, and we put that key comma value pair in the sorted dictionary. Then again we move to the next sorted value, that is the second highest, and we do the same thing. So we can now do print len of sorted dictionary and len of sorted values. We can just have a look. Now you can also see that there are like you can see it is there and this thing is there, which are also treated as words but they are not useful at all, so they are also having some frequency. So we can just get rid of those words, so removing the observable irrelevant words. So whatever you can observe through the output, you can just get rid of this, and our output finally would contain all the clean words. So all the words are now relevant, they are not irrelevant. You can see they are, none of them are stop words and all. So now we can go ahead with creating the data frame. I told that each of the words would be treated as a feature of our naive Bayes classifier. So we can just first we can just like give we can create np.0. So basically we are creating a data frame which has all the elements as zeros, and it has a particular shape. What would be the shape? That is the len of newsgroup dot target names, which is the number of columns, number of rows, and the number of columns is the basically the number of words plus 1. And the naming, you can name the columns of the data frame. So extrain dot columns equals to list of sorted ticked of keys. So these are the keys are the column names, and these belong to the particular categories. So category is the last column name basically. So now extrain of category is equals to the target names. Now we can see our text test also. If we do extrain of copy, it now looks like this, but we are now going to fill the table. So for I in range, we iterate through the length of the target names, that is we iterate to 20, and we take the class data, that is we take the training data of from our fetch 20 news group, and the class data contains the data of the ith target name, right? Because in the categories we have put the news groups dot train of target name of I dot data. So for j in class data, for k in j dot split, so we will just split by space. So we now have the words for if that particular word is in the list of sorted dictionary keys, then we increment the count. So in our testing data set, we go through all the words. This class data contains that. So in the this k is the particular word because we are splitting by space, and if this word lies in the list of sorted dictionaries which we have already created, then then that word would be incremented by some count. And you can see that we have filled the table of xtrain this way, and also xtest we can do in the same way. Yeah, just the same thing I have done with the xtest. Now we have the xtest also filled table. Now we can build the original xtest and ytest. So we are just taking all the rows, and we are removing last column. We are just taking the last column in case of ytest, and we are removing the last column in case of xtest. So from sklearn we are importing the naive Bayes classifier. So this is the multinomial naive Bayes. So we are creating a object handle, and we are just fitting xtrain comma ytrain. Now we can just predict using that. And if we I have already talked about in my classification video about the various matrices used to measure the accuracy in case of classification. So we can test on those matrices, and we will see that we have a perfect 100% accuracy on training dataset. I have already told you that this multinomial naive Bayes is used in cases when we have a lot of features. So here each of the word is used as a feature, and therefore we have a lot of features, and then this multinomial naive Bayes is giving a really great accuracy on such a kind of data. So we have 100% accuracy on the testing data set also. You can see the accuracy measures. So yeah, that's all from this video. In the next video we will probably be starting with the KNN algorithm, that is k nearest neighbors. So that's an interesting one, so we'll talk about that. Till then, thanks a lot.